Okay, so the next method you're going to learn is called completing the square. To be able to complete the square, you need to look for some key factors at the function. You should only use it when it's not easily factorable, when a is 1 and b is even. If those are not the cases, like if you do not have all three of these in the function, you should not be using completing the square. You're going to learn another method next time that's a whole lot easier, but the only time you should use completing the square is when you have these three requirements. Alright, so the steps to completing the square is the first thing should be put in the form ax squared plus bx equals c. So it's a little different than the factoring or another method you're going to learn. Your c has to be on the right side of the equal sign. So the first thing I want to do is move my c, which is 11, to the other side. To do that, I need to subtract 11. So now it says x squared minus 12x equals negative 11. Okay. From there, I need to do b over 2 squared. I need to find this value. This is going to help me big time. So my b is negative 12, and I square it. So negative 12 divided by 2 is negative 6, and negative 6 squared is 36. That 36, this number at the end, is always positive because you are squaring a number. Do not mess up and do not make it negative. It's always going to be positive. Okay, from there, that value I get, I'm going to add to both sides of the equal sign. You need to do it to both. What that means is, I'm going to squiggle this over here, x squared minus 12x plus 36 is going to equal negative 11 plus 36. Okay, you add it to both sides of the equal sign. Alright, so what I just did is now going to be allowed to factor my left side of my equal sign into a perfect trinomial. What that means is, let's first clean up the right side. Negative 11 plus 36 is 25. I can make this, I can factor this. So what two numbers multiply to 36 but add to negative 12? That would be a negative 6. And that would be the factored form of that. Where else did we see a negative 6? Our negative 6 is right here with a negative 12 divided by 2. It's a perfect trinomial, which means I can write it squared. And that is what we're going to want to do. Okay, you can skip this middle step and just go here because we know our b value, that negative 12 divided by 2 is negative 6, and that's what that q is. That q is going to be your b divided by 2 every single time. From here, I can now solve both sides, or solve for x. Remember, we're going to have no solutions, 1 or 2, and don't forget to include that plus or minus in front of your square root symbol when you are solving. So my first step to solve this is to take the square root of both sides to cancel out that 2, leaving x minus 6 equals, do not forget that plus or minus the square root of 25. Now you can ask yourself, what is the square root of 25? We know it's 5. How do I get x by itself? I add 6 to both sides. Now be careful. That plus 6 is going to go in front of the plus or minus. So ready? 6, I don't need the plus sign because it's positive, plus or minus 5. Now remember that plus or minus really means a positive 5 and a minus 5. So I break this guy up into two equations. X is going to equal 6 plus 5 for that plus sign, and x is going to equal 6 minus 5 for that minus sign. X equals 11, x equals 1. Those are my two x-intercepts. Alright, I know we're going to have to do a lot of these, so I'm going to work out a couple with you. We're just going to keep going. Alright, so my first step is to move my c to the other side. So I am going to add 3 to the other side. leaving a squared plus 2a. I'm going to leave a space for that number we're going to add in. That extra step now is the b over 2 squared. So 2, because that's my b, all over 2 squared. 2 divided by 2 is 1, 1 squared is 1. So I'm adding 1 to both sides. Now remember, I am going to just jump to the step here. The number I'm going to put here is my 2 over 2, which was 1. And I'm going to solve. So now I can take the square root of both sides, cancels those, leaving a plus 1 equals plus or minus the square root of 4. Square root of 4 is 2. So now I'm just going to move that minus 1 over. And like I said, that minus 1 has to go in front of the plus or minus. And now I have two equations. Negative 1 plus 2. A equals negative 1 plus 2. So a equals 1. And my second one is a equals negative 1 minus 2. A equals negative 3. Those are my two solutions to that function. Alright, let's try another one. First step is to subtract the 52. X squared minus 12x. I'm going to leave a little space for that number I add in. B, which is 12, negative 12 all over 2 squared. Negative 12 all over 2 is negative 6 squared, which is 36. So I'm going to add that 36 to both sides of the equal sign. This side is going to equal, let's see, negative 52 plus 36 is negative 16. And then my other side is going to be x. I'm going to follow the steps from the front. My b over 2 is negative 6, so minus 6. Now I'm going to square root both sides. That's going to be x minus 6 equals, can I have the square root of a negative number? No. So this actually has no solutions, because I cannot take the square root of a negative number. Alright, we are going to jump down to number 3. 3 and 4 just have a few extra steps. It's fine, it just has a few at the beginning. I only can have the c over here, and if you notice there's a plus 9 there too. That whole c has to move over. So the first thing I would do is either A, move it all to the left, or just adjust so only my numerical values are on the right. So I'm going to add the 4k over, and I am going to subtract the 9, and this is going to show you why. K squared plus 16k, those cancel, equals those cancel, and that equals negative 6. Okay? Do you see now that my c value is by itself on the right? Okay, so from there, I am just going to start. I am going to do my negative, or my b all over 2 squared. My b is 16. 8 squared is 64. So I'm now going to add the 64 to both sides of my equal sign, because it has to be balanced. It's a completing the square method. Okay. My right side simplifies to be positive 58. My left side, we know it's going to be squared. B all over 2 equaled 8, so plus 8 there. Alright, now I'm just going to solve for k. I'm going to take the square root of both sides to cancel. K plus 8 equals plus or minus the square root of 58. Is 58 a perfect square? It's not. I'm going to leave it like that. So now I'm going to subtract 8 from both sides, And remember that negative 8 has to go in front. You can leave your answer like this to say k equals negative 8 plus or minus the square root of 58, or you can write it as two separate steps. Plus the square root of 58, and your second one would be negative 8 minus the square root of 58. Okay, either answer is acceptable. Alright, number 4. Again, I want my numerical values to be on the right side, and I want all my variables on the left. So I'm going to subtract this 21 to the 6, and I'm going to subtract that 3p over here. P squared minus 14p cancels, equals negative 15, and cancels. By doing that, my a and my b are on the left, and my c is on the right. Alright, from there, I'm going to do my b all over 2, negative 14 all over 2, and square it. Negative 14 divided by 2 is negative 7 squared, which equals 49. I am going to rewrite it by adding 49 to both sides of my equal sign. Clean up the right hand side, which would get me 34. My other side would be squared. I have to remember what value goes here. It's that b divided by 2, which b divided by 2 is negative 7. I square root both sides now to solve for p. So now this side will say p minus 7 because those cancel. Equals plus or minus the square root of 34. 34 is not a perfect square, so I leave it like that. I need to add 7 to both sides of the equal sign. And that's my final answer, especially since I can't simplify that. You can also, like I said in the previous example, write it like that, where one answer would be p equals 7 plus the square root of 34, and your second one would be 7 minus the square root of 34. You can always get a decimal value. The square root of 34 is somewhere around 5.8. So if you really wanted to have an exact value, it would be 7 plus 5.8. P equals 7 minus 5.8. So by doing that math, one p would be 2.8, and the other p would be 12.8. Those would be the exact x-intercepts of your values, but you're always allowed to leave it as a square root since they aren't the perfect squares. Try the last one by yourself. I'm going to do it by hand on here, so you can just check your work as you are done. I know that's a little difficult, so just email me or Google Meet with me if you have any questions. Okay, if you have any questions, just make sure you come see me or you send me an email. Have a great night.